of code in a program. And then this piece of code, we happen to be using it in multiple places across our program. One way to better manage that is to extract that piece of code and then wrap a function around it. So then we can now invoke that function in that segment of our program where we need such code, if that makes sense, so that it helps us manage things more efficiently. So in this tutorial, we're going to be discussing Python functions. As you can see, there is a design on our screen which somewhat summarizes some of the concepts of Python functions. So here we have basic functions. We have the def statement, and then we have the function name, and this is taking an input and then it's returning this input using the f-string method, so to say. And then we are invoking it and then passing the value of our input here. Of course, we're getting the hello and then the value that we pass. Okay, so functions can be basic. It can also be complex, depending on what we are hoping to achieve with a function. Okay, look at this, for instance. It's a function parameters. So this is a default parameter. So like we define this function power. It's taking two parameters. The first one, the input is labeled x, and then the second one is labeled, I think this is exponential, exponent, and then we set a default value 2 here. So then when we do return x, exponentiation, then exponent, so this takes a default value of 2. So we don't necessarily have to use this anyway. Then when we invoke power here, we pass 3 for x. We didn't default to this. We passed 3 instead. But say we just pass 3 here, the second argument is going to take this default argument. So that's going to be 3 raised to power 2. Okay. So that's about. So here we have default values. I think we've talked about default values here. Default value here. There are two ways of defining functions in Python. We can use the def statement like we see here, and then we can use the lambda statement, which is for anonymous function. Okay, so I think the lambda statement allows us to concisely define functions. The syntax is not as long as when we go through this def statement. So there is a lambda function here. This is square. So we're going to be talking about functions as first class objects in Python, because here we're passing this lambda function as some kind of, I don't want to use variable now, some kind of object passed into these this variable square is pointing to this, is referencing it. Okay. I think I've done quite a bit in terms of introducing the concept that we're going to be talking about in this tutorial. So let's go to our terminal, our IPython environment, and then let's play with some program. Okay, so here we are in our IPython environment. If you don't know how to go about this, you should watch our previous tutorials. Okay. So like we said, there are two ways of defining functions in Python. We can use the def statement. What is it? This def statement. And then we can use the lambda statement for anonymous function. So let's play with, before we do that, there are some inbuilt functions in Python. Okay, the one we're very familiar with is when you have print. So this is inbuilt in Python. So it's a print ABC, for instance. So this is printing a string. So we press enter, it's printing. So this is a function. So this gives us an idea of how to invoke function. So the function in parentheses, then if the function is expecting some kind of argument value, we just pass the argument into the parentheses, and then depending on the type of value, the type of argument the function is expecting, we pass it here. Later on, we're going to be talking about Python types. Okay, there's a way we can use type in Python, much like we do when we do statically typed programming language. So, but in Python, what we do is duck typing. Anyway, so let's define. Anyway, this print can take other arguments, but I don't want to get into that. I don't want this tutorial to be longer than it needs to be. So let's define the function. Okay. In the previous tutorials, we've come across some kind of programming construct where we were trying to generate some kind of Fibonacci sequence. So let's use function to do that. So we can use function statement, which is def. So this is how we define function in Python using the def statement. So we start with the def statement, and then we do the function name. So in this case, we do Fibonacci. Okay, and then we have a parenthesis. So inside this parenthesis, if the function, we can pass parameters as we like. So I'm going to pass n here, and then so def statement, function name, parenthesis, pair of parenthesis. If the function is expecting some kind of value, so we're going to pass the input here, and then we have full colon. Okay, in another programming language, that would be a pair of curly braces, but in Python we have full colon, and then whatever we have here is our code block. Okay, so we have to work in line with this indentation, otherwise we're going to run into some kind of error in the course of executing our program. Okay, so here we have Fibonacci. We want to generate some kind of Fibonacci sequence in a list. So we better create our list now. So we can do Fibo equals empty list. Of course, at some point we have to populate this list because we're starting from blank list now, empty list. Okay, so go to the next line, and then we can say A, B equals B, then A plus B. Oh, no, I don't want, let's not do this because we're inside a function. We're not even like passing any value at all. So let's do A, B, then we do 0, 1. Okay, so we're starting from 0 like that. Remember, we say Fibonacci sequence, or is the Fibonacci series now, comprises of a sequence of numbers such that a number add up to the previous two numbers. Okay, so here we should, I think we're trying to start from 1 1 here. We're going to see how this is going to unfold. If you've watched our previous tutorial, you would have understood what we're trying to achieve here. Though here we are using function. Okay, so let's have some kind of condition. We can do y y, then we call the length object, y length fibo, okay, y length fibo is less than our input hen. Okay, what do we want to do? So we don't want the length, we don't want the length of our Fibonacci sequence to be more than n. So we want it to be less than the value that we are passing here. Okay, so what do we do? Then we can do A, B, then equals to B, and A plus B, like that. Okay, and then we can do Fibo dot append. What are we appending? We're appending A. Okay, so we have to return Fibo. Okay, so I need to break out of the this white code block, and then I go back to our function code block, and then we can do return our Fibo list. Okay, and then I will break out of this. Then I need to invoke this function Fibonacci and then pass the value of these inputs. Okay, so to invoke it, I'm going to write a function name, which is Fibonacci, like that, and then whatever I'm passing, say I'm passing 10 for instance, then enter. See, this works. So it's starting from 1, 1. Remember here, we said A to 0 here, B to 0 here. Python allows us to do this, okay? We could have done this line by line, but Python allows us to do this, okay? So to make our program short, so remember here we're doing A, B, then B, A plus B. So here A was set to 0, B was set to 1. So when we do A, comma B equals B, so 1, then 0 plus 1, so that's 1, 1, okay? So to start with, we're starting with 1, 1. That's why you're getting this. So this sequence is consistent with our idea of a Fibonacci sequence. Okay, so we can generate more if you like. So you do Fibonacci. If you want to do 12, see, it works. You can expand it however you like. It works. Okay. What else again? We encountered default value here. See, here we encounter default value here, where inside our parentheses we're passing parameter and then we're setting it to some kind of default value. So that default value is going to be some kind of fallback value in event that we chose to not pass a new value when we invoke our function. Okay, see here now, I'm coming. See here now, when this def power, this function power, you realize the exponent defaulted to 2, but then when the power was invoked here, we didn't bother with this anymore. We set our own exponent exp value. Okay, we don't have to do that if we didn't want to. We could have done power 3 and then the second argument would default to 2. Okay, so let's go back to our what is it called? Let's go back to our IPython, and then let's work with default. I'm going to go back to Fibonacci, but here I'm going to set some kind of a default value. So here let's have n, okay, and then n, okay. Then we can do A equals to 0, and then B equals to 1. Now we're setting default parameters here. Okay, good. So let's go. And then we can do Fibo like before. Fibo equals empty list. Okay, and then we can do Y length of Fibo is less than n. Okay, then we do A, B equals to B like before. Then we can do Fibo dot append A like that, and then we can break out of this while loop block, and then we can return Fibo like before. Now you realize here in this function we are setting our default values for A and B inside our function. What is it called? Inside this parenthesis here. Okay, so we're using default parameters here. Unlike here, when using default parameters, we're explicitly setting the values of A and B inside the function body. So here we are using default parameters. Okay, so we say return Fibo, right? Good. So we need to break out of this. Now if I do Fibonacci, say I pass 12. 12 will be the value of n. Okay, and then the next two arguments, we have set the default values there. So if I just do this, this should work. See, it worked. All right. Obviously, I don't have to use these default parameters if I don't want to. So I can do Fibonacci, okay, and then I can do 10, and then I can do 1, 2 instead. So this will override these two parameters, these two values, and then this should still work. See, so we're starting from 2, 3, 2, 3, 5, 3, 5, 8, like that. Okay, so that's default parameters. Okay, now there are times when we are defining the function and then we are passing inputs, we are passing parameters, but then we don't know beforehand, we don't know how many arguments we would eventually pass. Okay, so maybe we don't know, maybe the function is taking some kind of inputs from the user end, and then we don't know how many arguments the user would eventually pass into the function. There is a way to do that. We have these special form hags and quacks. We use this to catch all arguments that are passed. It's better I show you than for me to just talk about it. So we can do def, let's say catch all, for instance, and then we have these two special arguments, asterisk hags, okay, and then the next one is double asterisk quacks, like that. Okay, so a full colon, then we enter into our function code block. Okay, so we can do something like print. Say we print, what do we do? We can do print hags here. Hags equals, comma, then you can do hags here. Okay, you can also do print, what is it called? Quads equals, space it out, equals, okay, equals quads, okay, like that. So this function is not explicitly returning anything, okay. So this kind of function that causes side effects, but then it should do for what we're trying to demonstrate. Okay, so I need to break out of this code block, and then I can invoke our catch all function, catch all, like this. Okay. Now remember, we said the reason we're using these special arguments is because we don't know how many. The reason we're using these special parameters, hags and quacks, is because we don't know how many arguments will be passed here eventually. Okay, so now we can pass as many arguments as we want here. Check this out. If I do 1, 2, 3, okay, And then let's say I do A equals 5. Then I do B is equals to 10. See, look at how many arguments I'm passing here. This construct allows me to do this. You see? Okay. So let me press enter and let's see what will happen. See? It's printing what we have here. Say hags equals hags. So we're getting a tuple here, 1, 2, 3. Okay? Then for the quarks, you realize we are referencing integer objects 5 and 10. Okay? And then for our quarks, we're getting dictionary, key value pair, like that. Okay? We can play with this even more. We can do catch all. Okay? And then here, let's say we do, I don't know, some arguments. And then here we do, I don't know, let me say keyword equals, what should I call this? Let me use string. Keyword equals 2, 3, 4, like that. Okay. So if we do this, press enter, see, this still works. We can pass as many arguments as we want when we construct our function like this. Okay, guys? Okay. So, what else can we do? Okay, watch this. If I do this, for instance, if I do inputs equals, say I said tuple, okay, and then I do 2, 4, 6, that's inputs, okay, and then I do keywords equals, so let's see, I said it, dictionary here, okay, and then key, let me call key pi, okay, and then the value 3.14, like that, okay. Now check this out. If I do this function catch all, say I call it a catch all, I can pass inputs and keywords as, what is it called, using this construct. So I can do inputs, these inputs, okay, then I can do keywords, these keywords, okay, and then let's go. See, it's returning what we set here and what we set here. Okay. Now let's talk about anonymous lambda functions. Okay, like we saw here with what is it? Anonymous lambda function. See, let me expand this. See, this lambda functions, it's anonymous lambda function. See, we're having a lambda, then this is the inputs, and then this is what it returns. Okay, so here we're passing the square. We're still going to talk about Python functions as first-class objects. Okay, so let's go back to let's try to do something different from, well, not different like that, but then not necessarily the same thing. Okay, so here if we have, let's say we have had equals lambda. So when we're doing our anonymous function, we're using the lambda statements. Okay, so lambda x, y. So this takes two inputs. X, y are inputs. More like when we are passing parameters here. So you can think of x, y as parameters in anonymous function. Okay, so and then we have the function body here. Then we can do x plus y. Okay, then we need to invoke this function by calling this variable had. So we can do had and then we can pass the argument inside our had. So let's say we have 2, 5, for instance. Sure enough, it had 2 plus 5. Okay, so that's what is it called? That's a anonymous function. Now, this is roughly equivalent to this. Def had x, y, and then we do return x plus y. This is roughly equivalent to this. Okay, so here we could have done had, then 7, 2. So we still get, we still return, what is it called? An addition result. Okay, so let's talk about functions as first-class objects. Okay, in Python, much like our integers, strings, and dictionaries, functions are first-class objects. Okay, now when we say functions are first-class objects in Python, what we are saying is a first-class object is a program entity. A first-class object is a program entity that can, 1, it can be created at runtime. Okay? 2, it can be assigned to a variable or elements in a data structure. Okay? 3, function as first-class objects implies that functions can be passed as an argument to a function. Okay, that's 3. And then 4, it can be returned as the results of a function. So the summary of this is Python functions as first-class object means we can pass functions around, if you like. We can use functions more like we pass values, okay, around. You get what I'm saying? Good. Let's not dwell too long on that. Now, let's write some code to demonstrate some of this concept. Now, if, say we're trying to treat function like an object, okay? When you have an object, in object-oriented programming, we say object is an instance of a class, and then a class is a blueprint for an object, okay? So, more like classes having methods, okay, or functions, if you like, but in the context of objects, classes, functions are methods, because eventually when we do instantiate our class, we create an object, and then those functions inside our class we call on our object like methods. Okay, so okay, let me leave it like that. Let me leave it at that. All right, so let's look at a scenario where we are treating a function like an object. Okay, let's go back to, let's do factorial now. So def factorial. Okay, obviously factorial will take an input n. Okay, so what do we want to do? Remember how we do. So we can do return 1 if n is less than 2. Okay, so return 1. Get that? Else n multiply, what's that? N multiply by factorial. So this is a bit of recursion going on here now. Factorial, I want to be sure I got that spelling right. Then n minus 1, like that. Okay, so this is what we have. Then I'm going to break out of this. So then if I do factorial and then let's say I pass 40 inside. What do we get? See, we get the value of a factorial. Remember the way we do factorial. N factorial is, what's that? Is n multiplied by n minus 1 factorial. So if we have 5, if we're looking for 5 factorial, for instance, 5 factorial is 5 multiplied by 4 factorial. Okay? And then 2 factorial is 2 multiplied by 2 minus 1 factorial, like that. So here we're looking for n factorial. So this is n multiplied by n minus 1 factorial. If you're familiar with a mathematical concept, okay. So we can do factorial, and then we do 5 here. So we get 120, okay. We can even do factorial, and then we say 0. Remember, we've written a condition here that says return 1 if n is less than 2. So this is going to return 1. Okay. Now, the idea of writing this is to treat our function like an object. Okay. So how do we do this? How do we treat our function as an object? Wait, remember we said we have this type operator. Okay, this type operator, and then it takes an argument, and inside this argument we can pass our object there. So in our case, we have factorial. So let's check some information about this. Saying type function. Okay, of course we know factorial in this case is function. Okay, so this should have been class function anyway, but we're inside IPython. If we were to be inside our native Python environment, we should get some kind of class flag here, but we're just getting function here. Anyway, all right, so how do we treat function like an object? Now, in Python, we have, what is it called? We have these special methods known as dunder methods. Okay? Dunder methods. Dunder methods, they are, what is it called? They have methods that have preceding double underscore, and then after that we have, so preceding double underscore, then another double underscore after. Okay, so what I'm saying is factorial, then we can do dots. Okay, and then we can call our special method double underscore doc, then double underscore, like that. Okay, now if we press enter, what do we get? What is it? This is not, oh, I'm coming here. I'll go to factorial. I'm not coming, factorial 7 50. I was expecting some kind of information. Dot double like this. I was expecting this to give me some kind of information. I'm not getting that. Maybe it's because of the environment in which I am. Oh, I'm not getting anything. But anyway, this is one way to treat function as an object. See, we are calling this dunder method, this dunder construct on our function. So this is like an object now, more like you call a method on an object by using the dot notation. Okay. So this is the doc attributes. Okay. I was looking for the correct term to use for that. So there are other things we can do. So we can do fact. I'm sure if I were to break out of this and then go to native Python interpreter, this should generate some kind of additional information regarding what is it called, what we're trying to achieve here. So guys, you can try that on your own hand. I don't want to waste our time by doing that. Yeah, okay. So we can do other things like we can pass our factorial inside, we can reference our factorial from another variable. So we can do this, for instance. Okay. Sure enough, when we call our fact variable, see, it's giving us additional information on our factorial function. You see, this construct, you have this done the attribute main a, okay? And then it's saying dot factorial n, like that. So the idea is function as a first class, what is it called? Function as a first class object, okay? And I told you that the core idea of that is we're able to pass functions around, okay? So this is consistent with what what we're talking about, okay? What else can we do here? We can do, now, remember, we started with factorial as a function. Now we're using this variable fact to reference this factorial, okay? So in a sense, this variable fact is inheriting from this function body, okay? So which means I can call this fact and then pass this argument in, and it should still work like before, you see? So this behavior is consistent with the idea of a function as first class objects. Okay? All right. There are other things that we can do. We have an inbuilt function in Python known as map. So if you have this map here, okay, so what do we do here? We can pass our function factorial here, and then we can use the range method here, or the range construct if you like. So if you pass 11. Now, remember, we have defined the body of a factorial function prior to this time. Okay? Now we're using the map method to pass, what is it called? To pass our factorial function around. Okay? So whatever the body of this factorial function is doing, it's going to reflect in the outcome of the operation we're trying to do here. Remember, Python functions are first class objects, okay? So here within range 11, so essentially what we're trying to do is we're trying to generate factorial across this range, factorial values across this range, okay? So if we press enter, we don't get the result. See, get map at blah, blah, blah. So maybe this is specifying some kind of identity or whatever it is. I couldn't be bothered with that for now. So the way to generate the output is to use some kind of list, okay? So we can use the list constructor here, okay? And then here we can do map, okay? And then we can do factorial, okay? And then we can do range, like that. I hope this is correct. Don't run into any issue. Okay, so now hopefully we should be able to populate. Now this list, hello, it's a list constructor. It's saying perform this operation and then spill out the output inside a list. Okay, so if I do return, see, so we get our factorial from, okay, so this is 11, so from 0 to 10, okay? So when we had 0, remember, if you've been following, we wrote that condition that says if n is less than 2, return 1. So when it was 0, we had 1. When it was 1, we had 1, okay? So when it was 2, we had 2 factorial. So this is 1 factorial, no, 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial, on and on like that. Okay, good. We have, what is it called? We also have higher order functions. So when we say higher order function essentially is a function that takes a function as an argument and then returns a function as the result. Okay, that's a higher order function. Um, we've come across higher order function before, though we may not be, what is it called? We might not. Okay, let's play with an example. Let's say we have fruits. Say we have fruits, and then here we have cherry. Okay, and then we have apple, and then we have mango. What else? We have I don't know, what should we call this now? Pineapple. Okay, so we have fruit like that. All right. We have an inbuilt function in Python known as sorted, for instance. Okay, so we can do sorted. Okay, then we can pass fruits here like that. We can also pass one more. What is it called? We can also pass one more argument. Let's say key is equals to length. So that length are objects. So this sorted, it can take another argument like this. So if I press enter, sure enough, it sorts out our fruits in ascending. This is a function too. Okay, so it sorts out what is it called? It sorts out our list. The whole point of passing this is to demonstrate the idea of function as first class object. So more like we're treating this function internal as if it's an object, whereby fruits is the value, and then here this is our, sorry, fruits is the key, and then this is our value, so to speak, if that makes sense. So what else can we do? What if we do def reverse? Okay, def reverse. Now we have a word here. Okay, so we can do return word. Okay, this is now slicing. Remember, so we expect word to be some kind of list now. So this wants to slice, create a new list from here by moving one step. Remember, the construct is start, stop, step. So from moving from the first item in the list by one step like that, we're going to create a new list with this. Okay, so let me break out of this, and then I'm going to invoke this reverse, and in here, I don't know, what should I do? String, let me just do string like that. So what do we do? If I press enter, see, something's wrong. Okay, nothing is wrong. No, something is wrong. Okay, sorry. Nothing is wrong. I did exactly what it was supposed to do, because we're supposed to step by one, and it's actually doing that here. What I intend to do is def reverse, and then word. Okay, and then here I can do return word, and then here we have this, and then we have -1. So this will reverse it now. Okay, so then if I do reverse string again, See, it's reversed it like that. Okay. If I now do, watch this, sorted, and then I pass fruits here. Okay, and then I do key equals to reverse. Okay, let's see what we get. See, it's using the reverse. What is it called? Um, so it's sorting the list of words by their reversed spelling. Okay, sorting it by the reversed spelling. Um, I need to be sure this is actually doing what it's supposed to be doing. Okay, I think it's doing what it's supposed to be doing. Um, all right, guys. Let's stop for here. I don't want us to. I think we're dwelling on. We've dwelled. We've talked a bit about functions here. So if you guys want to learn more, you can check the internet and gather more information on functions. I'm going to stop here for now. Thanks for watching.